Now that we've done the player movement and the gold and dynamite movement, all that's left is the collision. So we're gonna make two functions for collision. This one will be player and gold collision. And that's gonna, first of all, we're gonna give it the money, a mutable version of it, so that we can actually change the money. And that's already a resource since we added it as a resource, we inserted it as a resource. We want this entity money, and then gonna create a set. Before we're using a query, now we'll use a query set because we want the player entity and we want the gold entity. So we'll pass in a query into here to get the gold first, get the transform of the mutable transform to actually change the gold's position once it hits the player. Then with gold. So we want an entity that has a transform with the component gold. And now we want another query. In this query, we're going to get the mutable transform again for the player. This entity will have a player component, so that's how we know it's the player. That's all we need for the header declaration. So we can just open up this function. That should give us everything. So this query set, we can't loop through both of them at the same time. Both these queries, we can only loop through one. So we can create two loops instead of one. Just create a for loop for each of them, basically. Calls from player data in the set dot q1, since q1 is player, mutable, and we want to iterate mutable iterator. We're using q1 because this will be the first query right here, which is the gold, and second query. So q position 0, q position 1, right? Like an array. And we're just gonna copy this again. And we're gonna paste this here. For this one, the gold data, we're gonna change the gold, right? We're gonna change its position, so we want to make that mutable. And then we're gonna add collision to both the player and the gold, so you have to give them like a box around the sprite. So I'll give it a size, but if you want, you could also pass in the sprite and get the sprite size, but I'll just give it a constant size. It doesn't matter either way, it's pretty much the same thing, right? Player size and gold size equal to, I forgot it, equal here, so it's a vector 2 new, and we'll give it 20 since the gold is a bit smaller than the player, right? So this is a vector 2, and we can't, like I said, we can't loop through both of these at the same time. So for the first loop, we're just going to get the player's position, take that position, compare it, see if they're colliding, basically. So I'll get the player's position right here, create this immutable variable, and call this player, let's go position, and we'll just assign it the vector 3, change the default value, nothing else. The 3, call the new function, and we'll just give it zeros. We'll change it. And now inside of the loop, we can grab that position. Player position is equal to the player data dot transition, and that will give us the position. Now over here, we can check the collision. So we can create an if statement called the collide function. The one thing I said that's not part of the prelude, which is right here, that's the one function now. That's how we're going to detect collision, by this one function. So it takes the position of the first entity, then the size of the first entity, then the position of the second entity, which is the gold data transition, and the size of the second entity, which is gold size. And then we want to call the sum method to make sure that this function, this if statement will only run if there's data actually returned. After they've collided, we're just going to reset the position of the gold data. So we can go gold data dot transition dot the y equal to, and then we can just grab this position we have, this random number we have here. And now I'll just put it back to the top of the screen if they collide. So we'll do the same thing for the x-axis. Equal to, again, just be random. Grab the x-axis position as well. And we could also, since we got the money here, resource mutable, we'll increment the money. We haven't made a function to change the money's value in the GUI, but we'll still change it here and print it to the screen to make sure it's really changing. Okay, that should work now. We just have to add this as a system so that it runs on every iteration of the loop. System, the collision in. Now there should be collision between the player and the gold, but not the player and the dynamite. Watch this and so there was no collision because we messed up right here. We said Q1 again, so we're doing the same thing. We were using the player in both times. Right here we want to use the gold, which is the first query. Now there should be collision. Hopefully. So let's see this, and there's collision. So you can see that the dynamite is going straight through the player, but once the gold hits, you can see it's disappearing. And let's see if we're printing out. We're not printing out money because we're not printing it. So let's print out the money to make sure that that's also changing. Until n. Probably not do it like that. Print out the money. Now we should see the money increment every time the player picks up a gold. Still no collision between the player and the dynamite though. Okay, there's our output. Now we look at this, looking at the screen, the bottom. Guess I can't see right now, but you can see we picked up 3, 4. And if we switch back to our console, you'll see right here it's printing out how much money we picked up right here, 7. So the game is still playing in the background. And once one of those gold hits the player, it's increasing the money by 1. So now to give collision between the player and the diamond, all we have to do, dynamite, all we have to do is pretty much copy and paste the same thing, and we'll change the function name. It's pretty much the same thing, except gold will use dynamite. And the dynamite is much smaller than the gold. It's a bit smaller, so we'll do 10 instead of 20 for its size. Should probably clean this up a little bit as well. Instead of being a gold size, we'll name this dynamite size, and then this shouldn't be beta. Copy and paste this into. Now we just have to add this as a system as well. We added the player with 2 gold, we'll add another system. Now that should work. And we should have collision, hopefully. See it, and so it crashed the game because it caused an overflow, because an unsigned int, and we tried to minus from an unsigned int, and it's currently at 0, and we hit this line and this line trying to minus from 0 and an unsigned end crash the program basically because of that. We can just put an if statement here and check if the money, if it's greater than 0, then we would run this line of code. So if it's greater than 0, they hit the dynamite, then we'll minus 1 from them. Other than that, we wouldn't minus. Okay. Now hopefully it will not crash. And it's not crashing anymore. So as you can see, when the dynamite hits the player, it's also disappearing. Basically, that's how normally people think it's disappearing. You know, it picked it up, but it's really just resetting the position and increasing and decreasing the point, right? So it hits a dynamite, decrease the point, respawn it at the very top, hits the gold, increase the point, respawn it at the very top, and now you have these entities spawning in randomly. But as you notice, we're able to move outside of the screen. We can also add a constraint so that the player can't leave the screen. Inside of this if state, this loop over here, what we can do is we can give the x-axis transition.x, and so we're going to only allow movement between a minimum and a maximum. So min.max. Going to restrict movement to this area basically, and a min and a max. So for a min, we'll do 370. And for the max, we'll do negative 370. That should stop the player from leaving the screen. And this is a float, so you gotta add a dot here. Now, as you can see, the player can't leave the screen anymore. Before he could go as far as he wanted, I'm pressing the left key, right, I can't go. That's minimum and maximum have been set on the position, so can't get outside of that. Now, the only thing left is that the point, the money is not updating inside of the system. It is updating the value, but there is nothing to essentially update this this text right here, this text section. There's nothing to update this. So we got to create a function to update that basically, so that every time this number updates, it would reflect on the screen. Create a function for that, money system, and it's gonna take a money. We're just gonna print it to the screen, so we're gonna need to take it mutably, right? So take it from res. And then I will take a mutable query, and this query we're gonna get the text mutably, and this text will return essentially all of the text on the screen, all of these texts. If we had more, we'll return all of them too. So we can unwrap the text to get its content. So let's do that first with a mutable variable. Call this text, so it will equal to the query dot single immutable dot unwrap, and this will give us the value basically that exists. If it doesn't, it would crash the program, and it does. There's an empty space in there. There's value. So text dot sections, and that returns an array of how many sections there are. So there's 2 sections of 0 and 1, and section 1 just shows money. Section 0 will show money, so we don't want to change that. Section 1 is where the value will go. So put section 1 dot value, and that value will equal to the value of money that's in the system. And the value of money that's in the system is an integer, unsigned integer, so we gotta cast that to a string. Then all we have to do is add this as a system so that it updates on every iteration of the loop, of the game loop, right? So apparently copy the whole function, not just the function's name. Okay. system. Now we run this, we should be able to see that the money increments when the player picks up a gold, and it is now 4, and when we hit the dynamite we'll lose money. 3, 2, 1, we're back down, and now when we hit 0 we don't decrement anymore because we're not going to go negative. We can keep picking up and we'll go back up. And that's pretty much the game. We can, to make it more stable, to optimize it, we could build this in release. We can build the game in release by doing cargo, build, 2 dashes, and then release. And that will take a while to build the game, but yeah, I'll just skip over this. Once your release build is finished, so you can see mine here is finished, you want to go to the directory that you saved your project. So mine's here on the C drive, then you want to go to the target folder, release, and then you want to get this exe file. And you want to copy it to the area that has the assets folder. So it needs the assets folder, it needs the images to run. Then double click this and you'll have the project running in release mode, which is optimized. Bevy Rust will optimize the project for you, so it'll run a lot more smoother now. So that's the project. We added collision between the objects, we added some points, we have movements, we pretty much have everything. If you're really interested, then I recommend you try to implement a menu maybe. But yeah, thank you for watching, and I hope you learned something about Rust and Bevy.